Okay, hey guys, it's Lorenzo. We're gonna continue with the topic of calculus. So basically, in my first couple of videos, we went over the process of going from a function of x to a derivative of x. So finding the derivative, that was the main goal in the last couple of videos. Now we're gonna go over something new, which is going in the opposite direction. So that's going from the derivative back to the original function. This is basically just finding first derivative, and the process from going from year to year is known as integration. So what you use is you use this symbol known as an integral. You use the symbol integral of derivative. That's going to give you back the original function. All right, and that's important because sometimes they can give you I don't know, a slope of a function, and then they can ask you, well, which functions could have this slope, and then you need to go through integration to find the actual functions which would have that slope. All right. So basically, it's actually pretty easy if you get used. It's basically just the opposite of differentiation. So if you have a function x to the power of n, you always have to write dx because we're integrating with respect to x. Alright? Well, we have to find a new function that if we find the derivative of it, we're gonna get this, right? Because we're going from this to this, but if we then find a derivative, we're gonna have to get back to there. Alright? So basically, what do we know from differentiation? That the exponent always goes down one. So what do you think is going to be with integration? Well, it's probably going to go up one, right? So it's going to be like that. However, let's say we find a derivative of that. We're going to have x to the power of n plus 1 times basically n, right? Because that's the chain rule. So it would be the derivative of this would go down one, and this would go down. Like, you'd multiply x by what the initial exponent was. So we'd have to divide it by n plus 1 to kind of cancel that out. Because now if we took the derivative of this, so if we said, all right, our function is x to the power of n plus 1, and we're going to find the derivative of that. And this is n plus 1. If you find the derivative, it's going to be x, n plus 1, the exponent is going to go down 1. So it's going to be x n times n plus 1, because the exponent always gets multiplied by the x value, but the n plus 1 is still going to be down there, which is going to cancel this, and it's going to give us what we wanted, the x to the power of n. You see, so you always just kind of have to figure out basically what function, if you took the derivative of, would give you back the original. All right. Because basically what we've just found is we found a function that has that derivative. So, and then usually what we say is, okay, you have to also add a constant c to it, because taking the derivative of this, the c is just going to disappear, right? Because it's just a constant number, and a derivative of a constant is just going to give you 0. So we have to add a c to it, a constant value. So usually we always add the c to it. But yeah, so there's a lot of just rules that are very similar to taking derivatives. So let's say we had the integral of k, so a constant, and yeah, if we had that, right, k dx. All right. Well, what do we take the derivative of to get just a constant? Well, a k multiplied by a value of x, right? Because taking the derivative of this x is going to disappear because it's to the power of 1, so it's going to be to the power of 0, which is just going to be 1 times k, so that's going to be k. So taking the derivative of this is going to give you back the original integral, which is what we want. And this is going to be plus c, again, plus a constant. Another couple interesting ones is if we have the derivative, or the integral of 1 over x dx, this is always going to be equal to ln x plus c. It's important because we use it a lot. For example, I can give you a quick example then. Let's say we have the integral, I don't know, 1 over 3x plus 4. dx. Alright, so it's 1 over something, so I already know that it's going to be ln 3x plus 4. However, if we take the derivative of this, it's still going to be multiplied by this 3, right? Because it's the chain rule again, like I discussed in an earlier video. So this has to be divided by 3. Because if this was our function now, like we can prove this again. If this was our function, wait, don't forget about the c. This is our function, ln 3x plus 4 over 3. We took the derivative of that. We're going to have 1 over 3x plus 4 times the derivative of the inside, and then times that 1 over 3, which is still there. These are going to cancel out. You're going to get this. The c that was there, that one also just immediately cancels out because it's a constant. Alright, a couple other ones. Okay, we have the cosine of x dx. That's just going to be the sine of x plus c, because taking the derivative, sine x was cosine x. Similarly, if you have the sine of x dx, this is going to be equal to cosine x plus c. However, it's going to be negative cosine x because the derivative of cosine x is negative sine, but we want that positive sine of x, so it's going to have to be negative cosine x. And last one, e to the power of x dx. Well, e to the power of x just always stays the same, so we're going to get e to the power of x plus c. Alright, if any of these confuse you, I did an earlier video on derivatives, which might help a little bit. But yeah, so integration is just the opposite of differentiation. It's pretty easy, pretty handy if you want to find the original function from the slope. Alright.